Hello guys. So today we are back with another video, and today we will talk about inheritance. Basically, we'll talk about class inheritance. So as you can see, I have bought a new webcam, and this way I hope it's more interactive for you. So let's start off by recapping. Last time we've seen about classes, and before that we have seen how control flow works, how basic types work, and today we're going to talk about class inheritance. You can find some recap on this website that I have created under the courses section, and here you will have all the slides about this course, in which I hope you can find some useful information and some useful recap. So today let's start with what we have, what inheritance means. So all classes in Kotlin have a common superclass, which is any by default, and this is the default superclass for a class with no supertypes declared. So let's see. Last time we had declared some classes, like it could be, yeah, sorry, it's still indexing here. It's taking a little bit long, but we had seen that we have created a customer class, for example. We can see it over here. And yeah, especially this one is a data class. But this class has the any as it's superclass. Let me check. Yeah, it says that YouTube is not receiving enough information. That's pretty strange. But I hope you can view it anyway. I think it's just a warning. Anyway, so this class implicitly inherits from any. Any has three methods: equal, equals, hashcode, and toString. Let's try and say that for example class empty inherits from any. Okay, it will say that it has no constructor, so I must declare the constructor. And what we can see here, which is what they're specifying also in the documentation, an operator, because it is also an operator. Let's by default, Kotlin classes are final, so they can't be inherited. And to make a class inheritable, we have to mark it with the open keyword. So as we have seen in other lessons and also here, this class, which is the any class applied to any Kotlin class, is declared as open. Otherwise, we could not declare inherit the methods from it. So if I do right click, let's see if I find it. Yeah, implementations, type definition, usages. What I want to show you is that, yeah, maybe it's easier in Android Studio. So customer, no, not this customer, but the one under secondary. So these classes, nope. We have under customer. So here, what I want to show you is if I create the brackets and I hit Control O, I imagine that's Command O in macOS, we can override and implement the members of Kotlin Any, which is the class that we are inheriting from. So basically, I can also select them all and click OK. And then what this will do is it will allow us to override all the methods inside the any open class. So as you can see, we have an override method here. If I remove it, it will say it has to have override as modifier. And here, what we could do is we could change the behavior of these methods. For example, the most simple way would be to say this is an empty string. Let's get back here. So I don't know the shortcut in here to do so, but maybe you can find it yourself. Control O. Is for Android Studio. So by default, if you don't have open, you cannot inherit from this class. To open, to declare an explicit supertype, place the type colon after a colon in the class header. So yeah, to declare the supertype of a function, as we have seen, you have to use the colon, and then you have to specify the class, and also to initialize this class. So you have to pass a constructor, otherwise it will say that this type has a constructor and must be initialized here. Okay, nice. So if the derived class has a primary constructor, the base class must it must be initialized in the primary constructor according to its parameters. If the derived class has no primary constructor, then each secondary constructor has to initialize the base type using the super keyword. So each secondary constructor has to initialize the base type using the super keyword. So we have like a secondary constructor which has to initialize the base type, so the view, by calling the super keyword, or it has to delegate another constructor which does so. So note that in this case, different constructors can call different constructors of the base type. Okay, so let's try and do this with let me think. If we had we had online course which was inheriting from the course class. I think we made this last time. So what we have to do if we don't have a constructor here, we must declare it inside our brackets, but yes, it's impossible without primary constructor. So I will have to delete this as well. And val is not, as you see here, val on secondary constructor parameter is not allowed. So we cannot do it in this case. But if we have a secondary constructor over here, like constructor, and then I don't know, we could say course ID only. Then we say default name, default instructor. Sorry. These, so we have a secondary constructor, okay. Let me see, primary constructor call, insert this, okay. It's asking us to use the primary constructor, so we're doing so. But we actually want to call the super in this case, which is course, and this will not have any of this, so we do super, and let's say what is saying now. Primary constructor call is expected. So since we have a primary constructor, in this case, we cannot call super directly. We have to call the primary constructor first. And then now I think we can call the super. It can only be used on the left side of a dot. So we have to do this dot super probably. Expression cannot be a selector. Super is not an expression. Left hand side of a dot. All right. I don't recall why this is not working. Yeah, because we have initialized it here probably. So the course is already initialized, and in this case, we cannot do what they're doing in the example. The only way would be this one that I've shown you. So let's create another class for this online course. So let's call this lesson.kt. And let's call this class lesson. And then let's have what could we have? Let me think about it. So let me think. Yeah, maybe something like educational content. Right, so now we have our open class educational content from which we will inherit. And now it will complain because we have not used constructor invocation, but we will do it in the secondary constructor as they're doing here. And here we'll put the ID of the lesson, or pi, maybe, in integers. And then we say, I now use the super, and so it will call the super class of the super constructor here. So educational time, we could have time also here, and we can pass time like this. Then if we have other constructors, we could also call them. So we can say time, and then one name. Let's do something like this. And then name on string. Yeah, insert this. And we have to pass time. Perfect. So we have our open class which with a private value name, and we can pass the name in also in our lesson, and then we can pass it to the secondary constructor of educational content. So basically, we have two ways to initialize the lesson, one with the time and one with time and name. And same goes for the educational content class. But basically, this name will not be accessible by the function lesson. So if I say print, like we could override the toString here. Let's see if override actions, override possible. So we have to override fun to string, and here we do return, and then we return the time. And yeah, we don't have, yeah, we would have to create the variable time. We cannot access it, and we cannot do it even here. So we have to private val names int equals owl, and then when we call the super here, we could do name equals yeah, this name equals name, and now we can access. Oh, I was in that. Sorry. Yeah, it's to be variable, and it has to be string. So this way we can use the name, but bear in mind that it's not the same that we're passing here. So here we might have had name to uppercase. Yes, it's going to be different now. Name to uppercase, and here we might. So this value might be different from what we have stored in our name. That's what I want to say. And this is how we use the super. We can show it. We will show it later. So Kotlin requires explicit modifiers for overrideable members and overrides. So yeah, you need to specify override each time you want to override a method. The open has no effect when added to members of a final class, a class without an open modifier. So basically, if you don't have open here, like if you have open function test, you can override this function here, but if you don't place the override, it will complain, as we have seen before. And if this class was not open, you could not override the method. And in fact, you can see it also here. Open has no effect in a final class. Okay, so basically, if you want to prohibit to re-override from lesson, you can do that with the final keyword. So let's make an example with the toString method. So since we know that each function overrides toString, we can do override toString. And in this case, I want to use the name as we have said before. And now you will see that this will win. Uppercase will win because I want to declare this as final. And if I declare this as final, here you will see that it is final and cannot be overridden. So the compiler would complain if I try to compile this stuff. And this might be useful if you want to have control over the toString or on other methods. So let's try and run it. Yeah, we're not We have not initialized the class object. So we go here, we go to play with classes inheritance, and over here we say PoliMi lesson. Then we have to specify all arguments, and time we will say 1, and name we will say Kotlin lesson 11. So we run it again, run. Okay, and we have name equals null. So let's see why we have name equals null. That's probably because we have not set this dot name equals name. And so when we were running it, we were not having any value. Now that we pass override, we change this variable and then we call the toString, we have the proper result. Let's go on with overriding properties. So as you can see, the overriding mechanism works also on properties in the same way that it does on methods. Properties declared on a supertype that are then redeclared on a derived class must have prefaced with the override operator, and they must have compatible type. Each declared property can be overridden by a property with an initializer or by a property with a get method. So let's see this for values. What we could say. Here is, since we have name as private, we could try with variable open variable time, and this could be an integer of null. Okay. Now, what we could do here is we could say override value time integer null. So yeah, it's a variable actually, sorry. So it will complain if you don't use the same, if you don't use value or a variable. What's nice here is that you can click on the IDE to go to the supertype or to the implementation of this, and that's pretty nice. Then we can do time equals time. So we are overriding the variable time from educational content. I don't know why you would do this in this way that I'm doing it, but you can. So I'm trying to show you that now we're passing some value and we're multiplying it here. And what I want to show you is that if we call, let's do like also time here. Let's print time as well. And then let's print this dot time here. Accessing a file property in time in constructor. Let's see what happens. It's only a warning. So over here we have overridden, and here I will say name and time. Let's run this. Yeah, before running it, we have to call test method. Let me close all of that. inheritance, lesson 1, and then we say L. So L is our lesson, and then we say L dot test. Yeah, we have print line. Let's run this. All right, so let's see what we have here. We have our constructor, and we're passing time times 100. So 1 times 100, so we're passing 100 here, and our time is a non-final property, so it will be overridden by our lesson, because as you can see here, we are overriding this value, so the super will go before, this will run before the constructor of the subclass, and this way the time 100 will be overridden. If you want, we can show it here. Run super and let's run this. So as you can see, the super runs first, then we're running the toString because we're calling the toString, and then we are printing with the test method the same stuff that we had over here. So that's pretty interesting because we're overriding the variable time, and so we're not picking educational content anymore. Yeah, the value mentioned here. Bear in mind that if you do this, it means that you will have some logical issues, because this would probably this property shouldn't be open in this case, because it can have side effects, like you can see in our example. All right. So you can also override value property with a var property, but not vice versa. So you could have said here value time. Yeah, but this wouldn't apply. That should be, yeah, sorry, I thought that was in the educational content. So if you're here, you can say value. Of course, this you wouldn't be able to do this. And here you could override with var. That's what they're saying, but not vice versa. So of course you cannot do vice versa, because a value is immutable and a variable is mutable. You could also use the keyword as part of the property declaration. So of course, guys, this was an example. It doesn't really make a lot of sense to call the super like this and so on. We would have to, yeah, we would have to use different parameters, arguments of the class. So let's if we want to make it more understandable, we would have to do this probably with the customer, and we could do it maybe like we could say user, and here we could say data class user, and then we can say value open value name string, and we have to mark the data class as open. Yeah, cannot be used with data class, sorry. So you have to create an open class as we're doing here, and now it's saying no value passed for name. And to fix this, I'm passing customer name as a name. But what we could do also here is we could say open value name. Yeah, sorry, not open, but override value name. Let's see what happens. Yeah, we can do that. So that's quite interesting. What we could do more is this. Yeah, so we'll say we need a getter. So this still works, as you see, and it's another way you could use to override the name inside our user. The one that makes more sense to me would be this one in this case, because now from here you could you can always use the name property if you want inside your functions. So if I do test, I can do this dot name as well as this dot customer name. Okay, so I can use both if I really want to. Derived class initialization order. So during the construction of a few instances of the derived class, the base class initialization is done as the first step. So we have seen this already. We have to use the initialize block as first step, which means that it happens before the initialization logic of the derived class running. Yeah, so we have seen this already. I don't want to mention it again. So the initialization block here will run before the derived class. So it will say that using any properties of the superclass may lead to incorrect behavior if you try to change them before they're initialized. So it is also saying that when declaring a base class, you should avoid using open members in the constructors. So as you see here, you should avoid using sides inside our constructor, like our initialization block or constructor, because this could lead to side effects, because you are changing maybe you are overriding the sides inside the derived class, and then you are using the sides inside constructor. calling the superclass implementation. So code in a derived class can call its superclass functions and property accessors, accessor implementation using the super keyword. We have seen this already. They're calling it again. So yeah, basically you can, on the override, we have seen this with the string or with the equals and hash code. We could do also something like this, like to super dot to string. This will call the super type of this class. Let's declare this empty class as this, as such, and let's try and initialize an object of this empty class now. So let's do PoliMi and initialize it with test. So test value, let's run this. Okay, so as you can see here, we're getting the yeah, we're not getting its output. Let me think why. Returns the string representation of the object. Why am I not getting? Maybe this is some kind of issue because we're calling, yeah, we're inheriting from any. Let's try and remove it. Nope, it's still the same because, of course, it's inheriting from the public open class any. And if I remove this, it should, yeah, it should print. So probably the override function in this case is modified after we initialize this block, I believe. And this is why we only see the object address when we run it like this. So this does not make sense in this example. I'm sorry. What we can try is we can maybe have another function test here that prints the name. All right, and then over here we override and we say open in order to override it. And now what I want to do is, yeah, we can say is let's try and return this. So get custom string custom name. Let's say like this. So my name is custom phrase name. Okay. And now we return a string. So custom phase name, and then we return a string. And now here we say return. Oh, sorry. Return is name, and then we can say equals to our super dot custom phrase name. So we have both phrases. Let's run this, radio run. And of course we have to call the customer inside our test, print on customer, and let's run it. So yep. Sorry. I have to run the method. So it's in the phrase, and I have to run it. So we can say Luca equals my name is Luca. So basically we are calling the super in a proper way now, and we're reusing the super method inside the subclass method. Let's get back to our code. You can do the same as you have here with properties, like you can call super border color, and this will call get black, and it will return black. Fill color will be black inside fill the rectangle. Inside an inner class, accessing the super class of the outer class is done using the super, and then you can say super add outer, and this is just a way of calling the outer of the outer class. So let's do it with the rectangle, so as they have here. Let's copy all. So basically you can see that it's referencing the super class, because we have our inner class here, and we're referencing the draw function from the super class. So let's declare this in our code, and let's see this example as well. Let's run it. So yeah, I guess we have to call yeah, in this case we have to call the filler. Let me check. So sorry, we have to call draw, because here we are instantiating filler and we're calling draw and fill. So I have to create an instance of fill the rectangle, and then I have to call draw function. Let's run this. Yeah, we have we're printing it. We don't need the print in this case. So you see we're calling drawn a rectangle filling, and then drawn a rectangle filled, drawn a filled rectangle with color black. Because as you see here, we have we're creating filler, and then we're calling draw and fill, and then we're calling super filled rectangle. So we are calling this function drawing a rectangle, and then we're calling fill. So we want to fill our rectangle, and then we say, okay, we have drawn a rectangle with this color, border color. And where this border color comes from, it comes from our inherited class. overriding rules. In Kotlin, implementation inheritance is regulated by the following rule: if a class inherits multiple implementations of the same member from its intermediate superclass, it must override this member and provide its own implementation. So to denote the supertype from which the inherited implementation is taken, use super qualified by a supertype name in angle brackets, such as super and then the class name. So, for example, we have a class which inherits from an open class, rectangle, and from a polygon. And interface members are open by default. So you need to, and yeah, you need to actually override them. If you don't, you will end up with some issues. So let's try and add this to our code. So we have interface, polygon, and we have our rectangle. Yeah, they have a square, so let's call this square, and let's inherit from rectangle and from polygon. As you can see now, I must implement the members of polygon. Otherwise, I will have an issue. So why is it? Yeah, this is an issue with the IDE. Probably it has told me that I need to override two draw methods, one from here probably and one from here. So that's an issue, JetBrains. If you're watching this video, you need to fix it. Now let's override this function with and let's call the super of rectangle. As you see here, you can do it, and then you can call draw, and you can do the same with polygon. This will call rectangle draw, and this will call polygon draw. Right? So polygon interface might have this, and rectangle already has its method. So let's call our square. Bam, passes draw. Let's run this, run, and that's pretty much it. So it will draw everything we asked for. So to make this a little bit more interesting and understandable, we could have val height integer and val width integer. Now here we have to specify the same variables that we have here. Yeah, if pass them here. Never used, and high is a member, so we need to add override but these are final, so we need to have open. And now we have to pass height and width. Okay, So now it's properly managed. And here a square only has a certain width or height. So we can say size, and you can say integer, and here we can say size, so that we're properly initializing everything. So now if I run this, yeah, this will say build failed because we have not passed anything to our filled rectangle and our square. Run. Yeah, now you can see we're drawing a rectangle 5 by 5, which is actually a square. So it's not a rectangle anymore, and we're drawing a filled rectangle with a 3 by 4, and as you can see, we're filling it as well. All right. Yeah, you can say square value is private. It's actually better to declare this as parameter since it won't change inside the square class. So we have seen the inheritance lesson, and I hope this was interesting for you. I didn't think I will go through the properties today. We will go on with it on the next lesson. I hope you guys enjoyed the new webcam and following this course with me. And if you need any tips, anything that you might want